In this lecture, we're going to learn about projections from the C++20 ranges library. Projections are a feature that is supported by a lot of algorithms in the library, and this is a feature that allows your algorithms to work on a given aspect of the types that you are storing in your collection. And this is best explained with an example. Suppose we have a point class, and it is going to be made up of two member variables, mx and my, and we are going to order points based on the distance. Here we have our three-way comparison operator, which is going to be used to generate comparison operators. And if we go down, we're going to see that this operator is going to compare based on the length. So the point with a larger length is going to be greater than another point which might have a small length. And the length is really going to be the distance from the origin point. If you suppose that you have a Cartesian system like this, and we have, for example, a point living at this location, this is going to be our distance, and we have another point living at this location, this is going to be the distance. The point we have here is going to be greater than the point we have here. This is what we are setting up with our comparison operator here in our C++ program. So the point I'm trying to make is that by default, points are going to be ordered by distance. But sometimes you don't want this. Sometimes, for example, you want a quick ability to order your points based on the mx member variable or based on the mx member variable for a small and quick thing you want to do in your C++ program. But that's not compelling enough to go back and change your comparison operator. For example, coming back and saying we want to compare points based on the mx member variable. That's really not what you want. You just want a quick way to compare points based on the mx or mx member variable. And this is something we can achieve with projections. Here is a simple syntax of how we can do that with our sorting algorithm. So by default, if we call our sorting algorithm like this is going to compare using the std_less functor, and this is going to be comparing points based on the less than operator, which is going to be generated from our three-way comparison operator. And this is going to be comparing based on the length, because that's what we set up in our three-way comparison operator. So if we print the points here, we're going to see that the point with the smaller length is going to come to the left, and the point with a greater length is going to come all the way to the right. They are going to be ordered from smallest to greatest. This is what we are setting up here. But as I said before, we might want a quick ability to sort our points based on the mx member variable. And we can achieve that using projections. A projection is something you pass as a third parameter, in this case here, and we are passing this as a lambda function. Let's make sure you can see this entire lambda function. This is our thing here. And this lambda function is going to take in a point object, and we are going to return what we want to sort based on. So how is this going to work? Well, the sorting algorithm is not going to pass points objects directly to the std_less comparator. What it is going to do is pass the data first in our projecting lambda function here, and it is going to return what we want to project on. In this case, it is going to return doubles because our member variables are double for the points class. And then we're going to be comparing these doubles, and our data is going to be sorted on the ordering that we do right here. And we are going to achieve the ability to sort our data based on what the projection here says, and it is saying that we want to order based on the mx member variable. This is what we can achieve here. There is another syntax to be able to do this. For example, you can pass the member variable directly if it happens to be public, and the syntax to do that is what you see here. We're going to pass the address of operator, pass the class, we're going to pass a pair of columns, and then we're going to say the member variable. You can even pass a member function, which is going to return what you want to sort based on. So you are really free in how you can set up your projections, and this is going to work really well. One thing you should know is that projections are not only available for the sorting algorithm. If you go in your ranges algorithms in the documentation, you're going to find that a bunch of algorithms actually support this feature, and I am just using the sort algorithm here to expose the ideas. For example, here we have a for each algorithm, which is going to be looping around doing things. We are going to be working on a vector of std pairs, and we're going to pass in pairs of data here. The data is going to be made up of integers and strings, and we can have our data here. Once we have the data, we're going to loop around doing things. In this case, we're going to set up a lambda function, which is going to be printing data. This is what we want to do. And we can use a projection to specify which aspect of our pair we want to print. In this case, we want to print the first member of each pair, and that's what we get if we do something like this. We can specify that we want to print first using the syntax here. You see that we pass the type using the address of operator, we pass a colon, and we say which member variable we want to print as we loop through our container with the for each algorithm, as we see here, and we're going to print our data with this statement. We can also print the second member, and we can achieve that using the syntax we see right here. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is projections. Let's grab the code from our template files and put that in place. And we can open this up in Visual Studio Code by dragging and dropping here, just like we always do. This is going to give us our starting point, the main CPP file. Let's clean it up a little bit, and we're going to include our algorithm header. Let's do that. And I think we also need our trusty vector container. Let's put this in. I am going to go back to the code and put in our point class because we don't want to set this up from scratch. You can grab the code for the point class from the resource section of this lecture. And if we do something like this, the point class is going to show up in our project. This is really cool, so we can include the header for that. And now we want to bring in our print collection function, which is a function template looping around a given container, printing things out. Now, let's head over in the main function and set up our example. We're going to set up a collection of points, and this is going to be an std vector containing point objects. We're going to initialize this way, and this is going to be creating points using a constructor that we have in point, taking two parameters in, and that's going to be this constructor here. This is a syntax we can use in our C++ program. Once we do this, we're going to have our points stored in our collection, and we can print them out. We're going to see them printed out, and our printing function is also going to give us length information. Let's see if I can show that to you. So this is our operator stream insertion. It is going to be printing point data, and you see it is going to show us the mx member variable, the my member variable, and the length information to be able to see how our points are ordered, because by default our points are going to be sorted using the less than operator, and we're going to see length information. I think it is a good idea to try and run this program before we do any kind of sorting. Let's pass this through our compiler. We're going to use GCC as always. The build is going to be good, so we can bring up a terminal window. Let's bring up a terminal window. That's what we want to do. We can clear and run Rooster. And if we do that, we're going to see that our points are going to be printed with length information. We have the first point here, and the length is what you have here. We have the second point with length information, and we have our third point with length information. Now we want to sort these points using our sorting algorithm, and we're going to be using a ranges version of this algorithm. And what I want you to see is that points are going to be sorted based on the length, because that's what our three-way comparison operator is saying right here. We're checking to see if the length is greater than the other point's length. If it is, we're going to say that this point is greater than the other point, and this is the logic we are using here. If this is confusing, please go back to the chapter where we learn about the three-way comparison operator, and you're going to see how we do this and what all this gibberish here means. What we want to see is how our points are going to be sorted, and we're going to print the collection again to see the points printed in order, and that's going to be in ascending order because we are using our std less comparator functor here. Let's pass this through the compiler to see this. We're going to use GCC as always. The build is going to be good, so let's clear and run Rooster. And we're going to see that our points are going to be ordered by distance. The point with the smallest distance is going to show up first, and the point with the greatest distance is going to show up last. That's the setup we have here, and we are able to order our points based on the distance. Now, this is all fine and dandy, but sometimes you don't want to sort points based on the distance like we are doing here. For example, what if we want to sort them based on the mx member variable that we have in our point class? Well, we can achieve that using projections, and this is going to give us the flexibility to change how things are perceived in our collection without needing to go back and change our operators, because there was a reason we set up this operator like this. So we still need this, but we also want the ability to be able to sort based on a given aspect of our aggregate type. So we can sort based on the mx member variable by using a projection, and that's what we're going to look at next. So we're going to put in the code to play with this, and then I am going to try and explain, and the syntax is really simple. You pass the collection you want sorted, and that happens to be our points container. We're going to sort based on the std_less functor, so we're going to order in ascending order, and then you pass what we call a projection. And this is what the compiler is going to use to know how your points are going to be sorted. And you're going to see that this lambda function here is taking in a point object because that's what we are storing in our collection. And then we're going to transform how our std_less is going to see what we compare based on. So the std_less functor is really not going to see point information. It is going to see double information, because the sorting algorithm is going to take each point and pass it through our projection here. And then what we get out of the projection is going to be passed back in the functor here. And that's what we're going to be sorting based on. This is how we can achieve the ability to sort based on a given aspect of our aggregate type. If we run our program, we're going to see that now the points are going to be sorted based on the mx member variable of each point. Let's pass this through the compiler to prove this. You're going to see that the build is good, so we can clear and run Rooster. And if we look at our projection on mx, we're going to see that the point with a smaller member variable for x is going to show up first, and the point with a greater mx member variable is going to show up last. And this is the order we can achieve. You see that we are no longer ordering based on the length as we did before by default, and we can achieve this using projections as we are doing on line 44 in our C++ program here. This is very important to understand. If you go back to the documentation, you're going to find that many algorithms actually take projections. Let's take a look at our sorting algorithm if we can even find it. Let's open this up. We're going to open the sorting algorithm, and we're going to use the ranges version because non-range algorithms don't have projections. This is a concept that was introduced in C++20. So if you go down, you're going to see that we have no such thing as a projection. But if we use ranges algorithm, we're going to have projections here. And this is what we just explained. You can pass a third parameter, which is going to be what your algorithm is going to use to decide what you want to sort based on. And if you go down, you're going to even find a bunch of examples, but I think our example here is much better and much easier to understand. It is also possible to directly sort based on a given public member of your class. For example, if our member variables are public, we can use a syntax like this to say that we want our points sorted based on this member variable. You can use a member variable directly like we are doing here. You can even use a public member function. You can do whatever you want. The point I am trying to make is that you can do something like this. So our points now are going to be sorted based on the my member variable, and this is our projection now. Let's pass this through the compiler to see this in action. The bolt is good, so we can clear and run Rooster, and we're going to see that our points are going to be sorted based on the my member variable. The point with the smallest my member variable is going to show up first, And the point with the greatest my member variable is going to show up last, as we see in our output here. Let's show you another example with the for each algorithm. This is exactly what we saw in the slides. We are going to set up a collection of std pair objects, and that's what we are doing here, and we're going to put in data. We have integer data and string data, and then we're going to print our things only focusing on the first member variable. We can achieve this using a lambda function projection, as we see here. Again, what we take in our lambda function is going to be what we store in our collection, and our lambda function is going to return what we want to sort based upon. This is the idea behind this projection here. In this case, we will be sorting based on the first member variable, and we're going to see that we are only going to be printing first member variables in our collection. We can also use the syntax here by passing in what we want to sort based on directly. This is going to print the same thing. We can also say that we want to print the second member variable in our pairs, and that's going to be printed out here, and this is going to be our string data. Let's pass this through our compiler to see this running. The build is good, so we can clear and run Rooster, and we're going to see that for the first two cases, we are going to print numbers 1, 2, and 3 because that's the first thing we have in our pairs. So this is the data we're going to print. And then for the last one, we're going to print the second member variable, and that's going to be our string data. And we're going to see 1, 2, 3 in string format. And this is really cool. This is what we can achieve with projections. This is all I had to share in this lecture. The main idea was that you could pass a projection to your sorting algorithm and tell it what aspect of your type you want the algorithm to work on. We saw that we could use this with our sorting algorithm. We saw that we could use this with our for each algorithm. And these are just a few examples. You can check the documentation to see which other algorithms can work with projections. And you can take advantage of this in your C++ projects if it makes sense for the problem you are trying to solve with C++. We are going to stop here in this lecture. In the next one, we're going to learn about views and range adapters in the C++20 ranges library. Go ahead and finish up here and meet me there.